Objective number 2, test hypotheses regarding two population standard deviations. Now that we know the approximate sampling distribution of the sample standard deviation of population 1 squared divided by the sample standard deviation of population 2 squared, and how to find critical values in the F distribution, we can introduce a procedure that can be used to test hypotheses regarding two population standard deviations or variances. Now, testing hypotheses regarding two population standard deviations. To test hypotheses regarding two population standard deviations, use the following steps provided that 1. The samples are obtained using simple random sampling or through a randomized experiment. Number 2, the sample data are independent. Number 3, the populations from which the samples are drawn are normally distributed. Step 1, determine the null and the alternative hypotheses. The hypotheses can be structured in one of three ways. If we have a two-tailed, the null hypothesis is population standard deviation 1 is equal to population standard deviation 2. The alternative would then be not equals. The left-tailed test, the null, again has the equality, but then the alternative is that population standard deviation 1 is less than population standard deviation 2. And then for the right-tailed, the null again is the equals or the equality, and the alternative hypothesis is where the population standard deviation 1 is greater than population standard deviation 2. So again, just make note that subscript 1 is population 1, subscript 2 is population 2. Now step 2, you select a level of significance, alpha, depending on the seriousness of making a type 1 error. Step number 3, you're going to compute the test statistic. The test statistic is with capital F with a subscript of 0, which is equal to the sample standard deviation of population 1 squared divided by the sample standard deviation of population 2 squared, which follows Fisher's F distribution with n1 minus degrees of freedom in the numerator and n subscript 2 minus 1 degrees of freedom in the denominator. Now the two approaches. If we do the classical approach, we're going to use table 9 to determine the critical values using the degrees of freedom in the numerator and denominator, and the shaded regions represent the critical region. So for the two-tailed, we have two critical values. One of them is f1 minus alpha divided by 2. And you can see here that we have the degrees of freedom in numerator, degrees of freedom in denominator, and we also have f with alpha divided by 2. Now for the left-tailed, it's going to be f1 minus alpha, because it's only one critical value. And for the right-tailed, it's going to be alpha, and it's going to be the right critical value, where the critical regions are in the shaded region. And then step 4, you're going to compare the critical values with the test statistic. So if the test statistic is less than the critical value, or the test statistic is greater than the critical value here, then we reject the null hypothesis. In the left-tailed, if the critical value is less than the left critical value, then we reject the null hypothesis. In the right-tailed, if the critical value is greater than that critical value on the right, then we reject the null hypothesis, which means that if any of these test statistics fall within the shaded region, then we're going to reject the null hypothesis, and then you would state the conclusion. The other approach is the p-value approach. So to approximate p-values using table 9, it is easiest if the hypothesis test is a right-tailed test for one-tailed tests. This is done by choosing sample standard deviation 1 and sample standard deviation 2, so that sample standard deviation 1 is greater than sample standard deviation 2. The approximate p-value is found by determining the area under the F distribution with n subscript 1 minus 1 degrees of freedom in the numerator and n subscript 2 minus 1 degrees of freedom in the denominator. Now for a two-tailed test, we find the test statistic so that the sample standard deviation of population 1 is greater than the sample standard deviation of population 2. Then the p-value is 2 times the area under the F distribution to the right of the test statistic. Or we can use technology to determine the p-value, and I will show you how the technology step by step, it's on page 582. And then step 4, then we have to compare, and if the p-value is less than alpha, then we reject the null hypothesis. Now, because the procedures just presented are not robust, minor departures from normality would adversely affect the results of the test. Therefore, the test should be used only when the requirement of normality has been verified. Verify this requirement by constructing normal probability plots.